In this set language session 2, let us discuss about subsets. What do you mean by a subset? Subset is nothing but, let us consider two sets. Let the first one be capital A and the next one be capital B. See this diagram. Here we have two sets A and B. Moreover, we have another one set, that is C. If you see here, the set B contains the set A as well as it contains set C. So, what do you mean by subset? It is nothing but a set which has the elements from its master set or the parent set. Here, B is the bigger set. It has the elements 1, 2, 3, 4, and 5. A is another one set which has 1, 2, and 3. Here, if you consider this set A, all the elements inside the set A, it belongs to set B also. No element is left. All the elements inside the set A is belonging to the set B. So this set A is a subset to this set B. Even if we consider set C, it has element 4. This 4, it belongs to this set B. So if we consider this total set, that is 1, 2, 3, 4, 5, set B, and if we consider set C, this C is taking elements only from set B. No element is outside this set B. So we can say this C is also subset to B. So subset is nothing but we are taking some elements, only some elements or full elements from a particular set. If we take like this, we can say that as subset. So if we consider here, if A and B are two sets, and if all the elements of set A belongs to B, then A is subset of B and it is represented by A is subset of B. So if you see here, you can clearly understand this A is subset of B. Even C is also subset to this B. So you would have understood what you mean by subset. It's very, very simple concept. Right. In the subset, we have two sets, that is proper subset and improper subset. What do you mean by a proper subset? This we can see by this example. Just see this diagram, you can understand it. If you see here, this A is the bigger set. B is its subset. For example, if I want to have another one subset C like this totally. So if you make a set like this, then that set will have the elements A, B, C, D, E, everything. The same elements totally A is also having. Both are equal to one another. If you select a subset like this, we cannot call that subset as a proper subset. If it is a proper subset, then at least one element should be left. Minimum one element should be left from this set. So when we can call a subset as a proper subset, first of all the elements should belongs to the set A. In the same time, at least minimum one element of this parent set or the set A should be left. If it is so, we can call this set as a proper subset. Now let us see this example, that is capital A is equal to A, B, C, D, E. This set A, B, C, D, E, this set, and our B set is B, C, D, E, and our B set is B, C, D, E. If you see, this set is subset to this, and minimum one element is left here. A is left here. All the elements that is inside the set B belongs to the set A. The same time, that is, if you consider the set B, you have B, C, D, E. This B, C, D, E is also inside the set A, so it is surely subset. But at least minimum one element is not here, which is in A, which is in the set A. So we can call this by the name proper subset. And this is represented like this. B is proper subset of A. Let us see improper subset. If all the elements of B belongs to A, that is, if all the elements of B belongs to A and all the elements of A belongs to B. What do you mean by this? For example, you consider the whole thing as set B. So if you consider like that, then this set B has all the elements which is in A. In vice versa, we can say this A has all the elements of set B. So totally in the improper set, we'll have A, B, C, D, E, which is in the set A. If it is so, we can call that subset as improper subset. As I told you, what do you mean by subset? If you consider this set A, you have so many elements, that is A, B, C, D, E. You can take A, this is a subset. You can take A and B, this is also a subset. You can take like this B, C, D, E, this is also a subset. Even you can take all these things, that is A, B, C, D, E, everything you can take. That is also a subset. Even you can choose an empty set, that is also a subset. In that, if all the elements are covered in that subset, that is improper subset. Minimum if one element is left, that is proper subset. Right. Now let us see this with another one thing, that is next one is power set. What do you mean by power set? As I told you, to have subset, it is very simple. You are going to choose no element or single elements or two elements or three elements, and you can take all the elements of the set. They are all called by the name subsets. If you collect all the subsets together, that set is called by the name power set. Now let us see an example. Let us consider a small example. Set A has 1, 2, 3. From this you can make so many subsets. You can choose all the elements, that is 1, 2, 3, or you can choose two elements, 1, 2, 2, 3, 3, 1, like that, or you can choose single elements, 1, 2, 3, like this, or even you can choose no element, that is empty set. All these things are its subset. If we collect all these subsets together, we used to call it by the name power set. So let us see its power set. It is represented by P of A. Now if you see, this is our power set. First we have all the elements, totally 3 elements in the parent set. All the 3 elements are written here. After that, one element is left. That is, after writing 3 elements together, now we are going to write two elements. 1 2, these two, then 2 3, then 3 1. That's all. There is no other way to write with 2 elements. After that, again we are going to leave one more element, so we can write only single elements. 1 2 and 3. As I told you, finally you can write, that is, you may choose no element, that is empty set. So now all the subsets are collected together. If we collect all the subsets together, we are calling that by the name power set, right? So power set is nothing but collection of all the subsets. Collection of all the subsets of a set is called power set. This is what that P of E. Now let us count it and let us write how many subsets are here, right? Moreover, as I told you, if you see here, if you compare this set with this power sets, the parent set has 1 2 and 3, but all these subsets is left out at least by one element. Here if you consider this 1 2, 3 is left. If you consider 2 3, 1 is left. So whenever we compare the parent set with the subset, minimum one element is not available in the subset. So these all subsets are called by the name proper subset. And if you consider this element, that is 1 2 3, as I told you, if you compare this subset with the parent set, both are equal, nothing is left. If a subset is like this, we used to call it by the name improper subset. And if you consider this empty set, it is a common set for all the subsets. So this is a proper subset which always occurs for any subset. So this is always a subset. Empty set is always a subset. Now let us try to count it. If you count this, 1 2 3 4 5 6 7 and 8 subsets are there. So number of elements or number of subsets inside this P of A is 8, and we can write this as 2 power 3. In general, if we have 3 elements, then number of power sets will be equal to 2 power 3. If we have 2 elements, then the number of power sets will be 2 power 2. If we have 5 elements, then number of power sets will be equal to 2 to the power 5. So if in the parent set, if we have n elements, then n of P of A will be equal to 2 to the power n. If number of elements in capital A is n, then n of P of A will be equal to 2 power n. Now let us do some problems. Let us consider a set, and let us think that it has 10 elements. Now we are going to find how many subsets will be there, or let us try to find the number of power sets. Let us consider the set by the name A. As it is declared, it has 10 elements, so we can write this as n of A is equal to 10. We have the formula for n of P of A, that is 2 to the power n. Here the n is 10, so 2 to the power 10. 2 to the power 10 value is equal to 1024. In vice versa, let us consider that they are giving us number of power sets and we have to find how many elements have been in the parent set. Now let us consider another one problem, that is n of p of a is given by 512 and we have to find n of a. It is very simple. We have formula n of p of a is equal to 2 power n. So we have to make this 512 to be in the form 2 to the power. So we can write this as 2 to the power 9. You know very well this n is nothing but number of elements in the parent set. If number of elements in A is n, then n of p of A is equal to 2 power n. Here we have n of p of A as 2 power 9. So this 9 is nothing but number of elements in the set A. So this n is the important one, that is number 9. That gives us n of A value. So I hope so you would have understood what do you mean by subset, what do you mean by proper subset, what do you mean by improper subset, and what do you mean by power set, and also how to calculate number of power sets if number of elements is given, and if number of power sets is given, how to find number of elements. Keep on practicing this type of problems and let us go in deep with operations, set operations in the forthcoming classes. Thank you.